Okay, so we were computing the variation of operation and maintenance cost with time. So we said it's over 1.04 to the power A3 minus 1. So this is for the economic analysis. The only difference for financial is the discount rate and the initial value of operation and maintenance cost. So for financial analysis, the initial value is 96 million of local money. And then when we apply the summation, we divide by the discount rate, which is 1.1 instead of 1.04. So here.
Doctor?
Yes?
Can you repeat why A3 minus 1?
Yes,
A3
I will. Of course, I will repeat. Look, in general, they can tell you, for example, at year 0, this was the price of a fuel, for example. And from now on, each year it will be decreased, it will be increased by this percentage, okay? So if you know the value at year 0 and you want to compute at starting from year 1, for each year you are dividing by 1 plus A to the power I, okay? So this is why then each time you say that the value is 1 plus A to the power the number of years. But in case I gave you the price for year 1, and year 1 is already calculated, and you need to start calculation from year 2 to the remaining years. So because for year 2 you will divide by 1 plus I one time, okay? So you should do to the power 2 minus 1. And you will continue to do this for the remaining years. I don't know if it's clear. If you want, I can repeat.
You mean انه المينتننس بنحسبه انه الير اللي بعدها فبنبلشها انه year 2 على اساس هي year 1.
يعني نحن عادة هي الفكرة انه عادة ما بنكون نحن بنعرف at year 1 الفاليو، بنكون نعرفها at year 0. اوكي؟ إذا أنا بعرف الفاليو at year 0 to compute at year 1 شو بدي أعمل؟ بدي أعمل أول شيء over 1 plus a to the power 1 صح؟ بيرجع at year 2 بدي أعمل over 1 plus a to the power 2. ساعتها بيكون الاندكس هو number of year. Okay, بينما if I know the value at year 1 already at year 1 I have it without dividing by anything, هي already given لإلي. يعني I want to start to consider values after year 1 for year 2, 3, 4, etc. Okay, so أنت إذا معك value at year 1 وبدك تعمل calculation at year 2, you divide only once, you divide by 1 plus a to the power 1. And to find at year 3, you divide by 1 plus a to the power 2. This means that for any year number n, you are dividing by 1 plus a to the power n minus 1. لأنه at year 1, the price is given and I want to compute the price for remaining years. Okay? بينما إذا بعرف أنا البرايس على الزيرو بالyear 0, I want to compute for year 1 and all remaining years, ساعتها the general formula is over 1 plus a to the power I.
بس انا ضغط لانه بالفيول برايس اخذناها to the power n انه as it is ما عملنا minus 1 او انا
لا
مغلط.
مبلا كمان عملنا minus 1. لا هي A3 minus 1.
اوكي
كلهم minus 1. اتفقنا؟
اوكي.
ليش كلهم minus 1؟ لأنه نحن معنا كل البرايسز at year 1. ما نحن عملنا لهم calculation at year 1 كلهم. اوكي؟ وساعتها we are computing for the remaining years فللكل الاكسبوننت حيكون A3 minus 1. Okay?
Deal, thank you.
Welcome. Any other question before we continue? Okay, so now we can compute the operation and maintenance for all other years. So we compute our table. Okay, now the last thing, we already computed all costs. We have now to consider the gain. Okay, but for the gain, we have a variable parameter because they told us that the price, okay, we should consider a range of prices. So they mentioned in the given that we should study prices between, so if we go back to the slides, Okay. We want to compute the price in local money per kilowatt hour. Okay. So we call this variable X, and we want to study X from 5 to 7.5. Okay. So now let us compute the gain function of X. So we know that to find the total gain, we should multiply the price X, which is in local money per kilowatt hour, by the number of kilowatt hour produced for each year, which is in kilowatt, the capacity is 50 times 1,000, because 50 is megawatt hour. We have 50 megawatt, and the number of hour is 4,000. So if we just multiply 50 by 4,000, we get the value in megawatt hour. Since we want it in kilowatt hour, we multiply by 1,000. Then we get the corresponding value. And since we want to express the gain in millions per local money, we divide by 10 to the power 6. So in total, we get that function of X, function of the selling price, in local money per kilowatt hour, the gain is 200 times X million of local money. And now we will start to vary X. We can take, for example, an initial value. Let us consider, for example, that we considered a value of 5. The first value, which is 5. Okay. This is the minimum selling price. To see if it's acceptable or not, so we do 200 times 5, it's 1,000. So the gain is 1,000 million of local money for year 1, of course. So if I put now the gain, okay, so this is the gain in economic analysis. What will vary now? The discount rate will vary. Okay, they told us in the given that for each year we have an increase in the selling price of 3%. Okay, so first the initial price was for year 1, 1,000. Then we should consider the increase of 3% for each year, and the reduction due to discount rate to get the net present value. So we should do 1,000 times 1.03, which is for each year the percentage of increase, over the discount rate, which is 4%, to the power A3 minus 1. Okay, so we can get then the value for year 2, and then we use the same formula for remaining years. Okay, now we'll do the same for the financial value of gain. So gain financial, for the first year, it's also 1,000, but now what will change is just the discount rate. Okay, so we'll use the same formula, but instead of doing over 1.04, we'll do over 1.1. So here, we just replace 1.04 by 1.1. Okay, now, once we got the different values, okay, we are ready to compute the economic present value and the economic financial value. So for each year, we can get the present value first of economic. So we should add the fuel cost, the economic fuel cost. So here, it's summation of. Okay, so we start from here. Okay, we should start for each year the economic fuel cost. We do minus because it's a cost, so minus I2. And for the salary also it's a cost, so minus the economic salary, minus the operation and maintenance economic cost, and plus the gain, okay? So we can obtain the value of We can obtain the value of the present value economy. Okay, we can do the same for PV financial, the present value for financial analysis. So we do the summation. We have first minus the fuel cost as the financial fuel cost, minus the salary financial cost, minus the operational and maintenance cost, and the plus the gain. We get the net present value for financial analysis. Now we'll do the same for the different years. It seems that this value of selling price is not very encouraging because we are getting negative values. Okay, so we can now compute the net benefit. So the net benefit over years, all we have to do is the summation. So here we compute the sum, the summation of these terms. And here also we do the summation. Of course, okay, it's positive, but it's not encouraging. And it seems the values are relatively small, because to know if it's encouraging or not, we should compare to the investment. We know that initial investment I0, which is constituted of the plant cost and the installation costs. We have computed already that for economic analysis it is 1,248 millions of local money, while for financial analysis it is 1,200 millions of local money. So now we can compute the net present value, because you know the net benefit, we should subtract from it the initial investment. So now the net present value is equal to the difference between the net benefit and the investment. So it's very bad here. We get a negative NPV. So for this selling price, of course, we cannot advise to go through the project. For both economic and financial analysis, it's not good. Okay, but it seems that for the financial analysis, the case is more acceptable. Let us check for the CER to judge. Okay, because it's not enough to consider the NPV, because we need a relative value, which is the CER. And we know that the CER represents the ratio of the NPV over the investment. So we get a negative CER, which is very bad. For both cases, it's negative, but for financial, it's more acceptable. So what we will do now, we'll say it's not advised at all to start with this selling price. So we cancel out the possibility of selling at 5 local money per kilowatt hour. We now should move to another value. Since the margin is between 5 and 7.5, we can try now the larger extremity to see if it will give good results or not. So if it will give good results, we can try to have a lower selling price. If not, we can stop here. If the largest possible price is not convenient, then this project is not viable on the economic level and on the financial level. So all we have to change is just the value of X. So here, for example, we said that X will be 7.5. So when you multiply 7.5 by 200, instead of 1,000, you'll get 1,500. And here also it will be 1,500. So all you have to change is here your formula. Instead of 1,000, it's 1,500. And you will consider it for the remaining years. We'll do this for both economic and financial analysis. So here it's 1,500. And we'll consider it for all other years. And now we can see that it's much better. So by just increasing the from 5 local money per kilowatt hour to 7.5 local money per kilowatt hour, we were able to have a CER for economic analysis of 2.89, which is larger than for the financial analysis. So we can say that if we use this selling price, it's advised that to have this project on economic and not on financial level. So we suggest that the government should go through this project, not a private owner.
Doctor,
now, yes.
Can you remind me what's CER?
Of course. CER is the capital enrichment rate. It is the ratio of the net present value over the investment. Okay? Because if I tell you you are doing a project and you will gain $10,000, you cannot judge if this $10,000 is good or not if you don't know the investment. And if your investment is $50,000 and you gain, let's say, 10,000, it's good. But if your investment is $1 million and you just gain 10,000, it's very bad. This is why we need a fraction, a relative value, which is the CER, which will divide the net present value over the initial investment. Okay?
بس مش هي ال ROI ولا لا؟
لا لا ال ROI هي rate of return on investment. اوكي هي اذا بدك شو هو الديسكاونت ريت اللي نحن بنسميها هون IRR بهيدا الكورس. اوكي internal rate of return. What is the rate needed in order to have a net present value of zero? هيدا هو ال internal rate of return. اوكي
thank you.
Okay. So now it is much better. We got a CER that is very encouraging. It's much larger than 30%. So by just having this change in price, we were able to have a much better profitability on the economic and financial level, but better on economic level. You can say, you should check if this price is competitive with the market or not. So you have the possibility of reducing the value of the price to be more competitive. So to know now the amount, the extent to which you can reduce, you should do some parametric study, and you should try a new value. So instead, let's say of 5, let us consider instead of 7.5 x, let us consider x equal to 6. So instead of 1,500, so it's 1,200. If we try it, so this is what we mean by the sensitivity analysis that should be conducted in economical study. We should try to know what is the range of possible values we can play with. And depending on the market we are investing in, we can decide on the optimal price to use, because we should remain competitive in the market while at the same time having an acceptable CER. So here, for this price, the CER is still acceptable, and the price is relatively smaller, so it's more competitive. So we can, if I ask you, for example, what is the selling price for which the CER is 30%, you should try. Okay, so here in the example, I did for you several possibilities. Okay, so we can see first, we started by if you do 5, we said it's very bad, so we get negative values for CER and NPV, not acceptable at all. Then we switched to 5.875. We got both CER larger than 0.3. So we can say that this is relatively acceptable. In case you want to have 0.3, you need to do more trials to know what is the exact value of X for which the CER will become 0.3. Okay, but from here, this X is acceptable. And of course, larger is your X, larger will be your net present value, and larger will be your CER. But you should make sure that you can still remain competitive in the market to be able to sell your product. Okay, so here in these tables, we are investigating different values of X. And for each value of X, we are calculating the possible NPV and CER. And for 7.5, it's very high. It's a very high CER, but it's questionable if we can reach this value. So we should make sure that it's an acceptable price. Okay. Any question on this? So this is the part that you are responsible for the exam. If you have any question while studying, feel free to contact me anytime, okay? If anyone needs any help also for the project, let me know.
Thank you, Professor.
Welcome, welcome. Bye.
دكتور